Hello students, I am Prem Dhawan and I will be discussing with you about the Aldol condensation and Cannizzaro reactions of aldehyde and ketones. But before we start, please subscribe to my channel if you haven't already and press the bell button so that we can notify you whenever the next video comes. Let us discuss some important name reactions of aldehydes and ketones. And the first important name reaction is Aldol condensation. Now the first point is that aldol condensation is a reaction given by aldehydes and ketones containing alpha hydrogen. For example, CH3CHO is the simplest aldehyde which contains an alpha hydrogen, so can give aldol condensation. Propanol gives aldol condensation, it contains alpha hydrogen. Acetone gives aldol condensation, it contains alpha hydrogen. So the first of all you have to see whether the alpha hydrogen is present or not present. Second, this aldol condensation, it takes place in the presence of an alkali. So it requires the presence of an alkali. And alkali can be NaOH, KOH, barium hydroxide. It can be sodium carbonate also. So we use dilute alkali to perform aldol condensation. Now the third point is that aldol is the common name for beta hydroxy aldehyde or ketone. Aldol contains this type of group. This is beta hydroxy aldehyde or ketone. And the fourth point is that aldol is a name used because the final product contains an aldehyde group and alcohol functional group. Even if you are preparing aldol starting with ketone, but still we retain the name aldol. Then the fifth point is it's a condensation. Now condensation is a reaction involving two aldehydes or two ketones with the loss of water or without loss of water. So condensation means it's a reaction between the two aldehydes or two ketones or one aldehyde, one ketone with or without loss of water molecule. But one of the compound must contain an alpha hydrogen. The next point is that in this aldol condensation, alkali act as a base. This is the mechanism involved in the aldol condensation. So we use an aldehyde or ketone containing at least one alpha hydrogen. So this is an aldehyde containing alpha hydrogen, and alkali acts as a base. So this base attacks at the alpha hydrogen and removes this alpha hydrogen to give this carbanion. This is carbanion, and this carbanion is resonance stabilized. This is called enolate ion. This is step number 1 in the mechanism. Now step number 2 is this enolate ion acts as a nucleophile and adds across the carbonyl group of the second molecule. Now this is second molecule, may be same or may be different. Now this step is called nucleophilic addition. And the step number 3 is the protonation of this negatively charged oxygen. And this is called beta hydroxy aldehyde. So this product is called aldol. So reaction takes place in 3 steps. First step is the formation of enolate ion using alkali as a base. Second step is a nucleophilic addition across the carbonyl group by an enolate ion. And the step number 3 is the protonation of this negatively charged oxygen to form the final aldol. If you want to write the aldol directly, then you have to follow these type of steps. Now, for example, you are given this. Ethanol acetaldehyde is being treated with dilute NaOH. Now, our aim is to write the final aldol A. Now, if you want to write the final aldol A, you follow this sequence of steps. You take 2 aldehydes and write one of the aldehyde in this form, highlighting the carbonyl group. And we use a name called substrate. And since the alpha hydrogen of aldehydes or ketones is acidic in nature, you write the second molecule of the same aldehyde in the form of an enolate. And we also know that the main reactions of the aldehyde and ketones are nucleophilic addition reactions. So the addition takes place across the carbonyl group. H adds to oxygen, and this negatively charged carbon adds to the carbonyl carbon. And the product obtained is called aldol beta hydroxy aldehyde. And this product is named as 3-hydroxybutanol. And this is our product A. Now, when this aldol condensation takes place between the two same aldehydes to same ketones, then it's called self aldol condensation. So this is an example of a self aldol condensation, but do all these things like substrate, enolate in your rough work. And write this final product 3-hydroxybutanol as compound A. Now, second example is this. This is called propanol. Now we are reacting this compound with dilute NaOH. Again, our aim is to write the structure of this compound A. Now, this is again example of self Aldol condensation. So you write one of the aldehyde as a substrate, highlighting the carbonyl group. And write the second aldehyde in the form of an enolate, and split only the alpha carbon in the form of a cation and anion. Nucleophilic addition takes place. H adds to oxygen, carbon adds to carbonyl carbon. And make sure your product is a beta hydroxy aldehyde or ketone. Only then the product is called aldol, otherwise not. This is alpha carbon, this is beta carbon. So my product is beta hydroxy aldehyde, so this is called A, and write this A as your final product. And these aldols on heating, they undergo dehydration to form alpha beta unsaturated aldehyde or ketones. So aldol on heating undergo dehydration, loss of water to form alpha beta unsaturated aldehyde or ketone. For example, this is beta hydroxy aldehyde or ketone. And they always gives a double bond between the alpha and beta carbon. For example, this is 3-hydroxybutanol. And on heating, it undergo dehydration to form a double bond between the alpha and beta carbon, and the product is called but2-enol. And this has a common name also called crotonaldehyde. Now we take another example. Suppose you are given this. This is called cyclohexane carbaldehyde. And this cyclohexane carbaldehyde can also undergo self Aldol condensation. So again you write the product A, and to write the product A, you write one of the aldehyde as a substrate and the second aldehyde as a enolate ion. This is substrate and this is our enolate. This is our alpha carbon. So H adds to oxygen and this alpha carbon attacks at the carbonyl carbon. So this is my enolate and this is substrate. And this is the product form. Make sure it has to be beta hydroxy aldehyde or ketone. This is alpha carbon, this is beta carbon, so this is beta hydroxy aldehyde, so this is my product A. Now one more example of self Aldol condensation. Now suppose you are given this acetone. Now acetone also contains alpha hydrogen. So now my question is acetone when treated with dilute barium hydroxide, it gives compound A. A on heating gives the product B. So question is, what are the structures of A and B? Now the first step is self Aldol condensation. We write in our rough work one of the acetone molecule as a substrate highlighting the carbonyl group. So this is substrate, and write second molecule of acetone as enolate involving alpha hydrogen. So this is my enolate. Nucleophilic addition takes place and the compound A is obtained. And again you make sure aldol has to be beta hydroxyaldehyde or ketone. So this is my product A. And this on heating undergo loss of water to give a double bond between alpha and beta carbon. So this is product B. So in this question, this is the structure of A. And this is structure of compound B. So when you're writing answer, you just write the structures of A and B. But we can have an aldol condensation involving two different aldehydes or aldehyde and ketones. So when we are using two different aldehydes or aldehyde and ketones, then it is called crossed aldol condensation. So it's a condensation between two different aldehydes or ketones, or you can have a aldehyde and ketone. But crossed aldol condensation is important when one of the aldehyde or ketone has no alpha hydrogen present. For example, this is called benzaldehyde, and benzaldehyde has no alpha hydrogen present. And we are reacting it with acetaldehyde, which contains 3 alpha hydrogens. In the presence of dilute NaOH and heat. Now, since benzaldehyde does not have any alpha H present, benzaldehyde cannot act as an enolate. So we have to take benzaldehyde as a substrate only. Again, in my rough work, I am taking benzaldehyde as a substrate. And we write acetaldehyde in the form of an enolate ion. Nucleophilic addition takes place. It gives an aldol. And this aldol on heating gives a double bond between the alpha and beta carbon. So this is our final product. So we write the final product as alpha beta unsaturated aldehyde, and this product has a common name called cinnamaldehyde. Cinnamaldehyde. And similarly, we can also have a cross aldol condensation between the methanol and ethanol. Now again, methanol does not have any alpha carbon, so there is no alpha H present. So methanol acts as a substrate only, and ethanol has 3 alpha hydrogens present, so ethanol will act as a enolate. In the presence of dilute NaOH followed by heat, it gives an alpha beta unsaturated aldehyde, and the structure of this product is CH2CHCHO. This is called acrylaldehyde, common name, and has a IUPAC name called a propanol. Suppose we have two different aldehydes and each having an alpha H present, then the number of products are formed. For example, this ethanol and propanol. Now each one is having an alpha H present. So in this crossed aldol condensation, 4 products are formed. One is the self aldol condensation of ethanol. This is called 3-hydroxybutanol. Second is self aldol product of propanol. It's called 3-hydroxy. This is called 3-hydroxy 2-methyl pentanol. And the third is the crossed aldol product in which the ethanol acts as a substrate. And this product is named as 3-hydroxy 2-methyl butanol. And the fourth product is when propanol acts as a substrate. And this product is named as 3-hydroxy pentanol. So the 4 products are formed if both the aldehydes have an alpha H present. Now we have another example of crossed aldol condensation. Now suppose you are given this CH3CHO and ketone. So aldehyde is ethanol and the ketone is propanone. And we are reacting it with a dilute NaOH and followed by heat, and the question is what is the structure of this major product A. So how do you decide which one should we take as a substrate and which one should we take as a enolate? Now if you look at the mechanism, this reaction is an example of a nucleophilic addition, and for nucleophilic addition to take place, your parent carbonyl compound should be less crowded. Now since ethanol is a less crowded aldehyde, you take ethanol as a substrate. So this is ethanol acting as a substrate, and propanone act as an enolate. Dilute NaOH. So first the aldol is formed. And this aldol on heating gives the product A. Loss of water takes place. So this product is called a product A. But aldol can be intramolecular aldol condensation also. So we'll take one example of a intramolecular aldol condensation. For example, you are given this aldehyde. This is called hexane 1,6 diol. Now in the presence of dilute NaOH, this can undergo intramolecular aldol condensation to form this product. And again, you make sure it has to be beta hydroxy aldehyde or ketone. So this is my aldol. And on heating, undergo dehydration to form alpha beta unsaturated aldehyde or ketone. So this is one example of intramolecular aldol condensation. But once you have an aldehyde group present, then even the aldol can give all reactions of the aldehyde group. For example, this is CH3CHO, ethanol on reaction with dilute NaOH, it gives an aldol, 3-hydroxybutanol. And this 3-hydroxybutanol can be changed into number of other compounds. For example, if you reduce it with NaBH4, NaBH4 will reduce aldehyde to primary alcohol. So the product obtained is this. This is called butane 1,3 diol. And if you heat this compound, it can undergo dehydration to form but2-enol, and but2-enol can be oxidized to butanoic acid too by using Tollens reagent or Fehling solution. So number of conversions can be performed via aldol condensation. Now the second reaction is called the Cannizzaro reaction. Another very, very important reaction of aldehyde. Now Cannizzaro reaction is given by aldehydes without alpha hydrogen. For example, methanol, it does not have any alpha carbon, no alpha H, so methanol can give Cannizzaro reaction. Benzaldehyde can give this reaction. You have a alpha carbon present, but there is no alpha H. Second point, it requires the presence of concentrated alkali. KOH, NaOH, anyone you can use. And the third point is that Cannizzaro reaction is an example of a redox reaction, in which one of the aldehyde gets oxidized to carboxylic acid, and the second aldehyde are reduced to form primary alcohol. Next point, that Cannizzaro reaction can also be a self Cannizzaro or cross Cannizzaro. No aldehyde should have an alpha H present. If alpha H is present, then the aldehyde will undergo aldol condensation and not Cannizzaro reaction. So we take this first example. It's a methanol. So we write methanol 2 times, SCHO plus HCHO. This is an example of a self Cannizzaro in the presence of concentrated alkali, KOH. Now one of the aldehyde gets oxidized. And aldehyde on oxidation gives a carboxylic acid. But since the medium is alkaline, you won't get the free acid, you will get a salt. So it gives a potassium salt. This is called oxidation. And the second aldehyde gets reduced to form a primary alcohol. And any compound having this group is called primary alcohol. This is called reduction. Now, if you look at this example, this reaction involves the oxidation and reduction of the same aldehyde. And you know, when the same substance gets oxidized and reduced, the redox reaction is called a disproportionation reaction. So this is an example of, or we can write this is a disproportionation reaction. Now, second example is this benzaldehyde. So it combines with itself, called Self Cannizzaro reaction, in the presence of concentrated NaOH. So one of the aldehyde gets oxidized to form a sodium salt, and the second aldehyde reduced to form a benzyl alcohol. This is also an example of a self Cannizzaro. Now we'll take the last example, and that is example of a cross Cannizzaro reaction. If you are given two different aldehyde and each having no alpha H present. For example, this, it's a methanol and benzaldehyde. It's a concentrated NaOH. Now, in case of a cross Cannizzaro reaction, the less crowded aldehyde gets oxidized. So the products are sodium salt of a methanoic acid and the benzyl alcohol. Less crowded aldehyde gets oxidized. And in this Cannizzaro reaction, this alkali acts as a nucleophile and not as a base. Like this. This is methanol and this is alkali, act as a nucleophile, attacks at the carbonyl carbon. And the second step is there is a transfer of H negative. This is second step. And the second step involves the transfer of hydride ion. And this is the rate determining step. To give methanoic acid, plus this is called methoxide ion. But methoxide ion is a very strong base, a formate ion plus methyl alcohol. So this is about the important name reactions of aldehydes and ketones. That's all for this video. I hope you got to learn something new, and if you did, then please press the like button and share this video with others. And also, if you have any doubt, any question, please note it down in the comment section. Thanks for watching. See you next time.